the process is going to behave, what a various things it is going to do, how it is going to proceed. Then after priority scheduling, we have one more scheduling algorithm called as round robin scheduling algorithm. Okay, we have one more scheduling algorithm called as round robin scheduling algorithm. Okay, we'll see that. We'll see for today's class. We'll see what is round robin scheduling algorithm. So here, when we take something like round robin scheduling algorithm, we need to remember few points. Main thing that we have to remember is whenever we come to this round robin scheduling algorithm, it is going to follow a method called as first in, first out. If you remember, that was a first come, first serve scheduling algorithm, which we have seen in the very first. As the process is coming in, it will go in the same order. So round robin is also going to follow the same order. First process, second process, third process, fourth process, like this, it is going to be in the same order. But difference is in first come, first serve, it is going to complete the things and it is going to come out. But in round robin, it is not going to do that. It is going to divide the things. Like for example, CPU running time is there. Running time will be executed for certain time, like 5 milliseconds, 10 milliseconds, 20 milliseconds. That is, first process has to execute for 5 milliseconds. After executing, it has to go back to the queue. Then second process will execute for 5 milliseconds. Then it will go back to the queue. Then third process will execute for 5 milliseconds. Then it will go back to the queue. After third process, fourth process will execute for 5 milliseconds. It will go back to the queue. Then after fourth, if there are no other processes, again first process will come and continue its execution from where it has stopped. Then again it will execute for 5 milliseconds. So like this, it is going to work in a round robin way. That is why it is called as round robin scheduling algorithm. And every process will get the chance here. Every process will get the chance over here, and they will be executed for certain time. They are going to be executed for certain amount of time. That is what is called as round robin scheduling algorithm. So if we take the things, we have few points about round robin scheduling algorithm. I'll explain those points. So in round robin scheduling algorithm, every process, okay, gets a small amount of time. That time is what we call as quantum time. Okay, that is the 5 milliseconds or 10 milliseconds which it is going to execute is what we call as quantum time. Okay, and this time usually will be from 10 to 100 milliseconds. Okay, it depends. It depends on system to system. After the time has elapsed, again the process will go back to the queue and it will come in the queue order. That is what is called as round robin scheduling algorithm. Okay, if we take the process, suppose there are n processes in the queue. Let us say that there are n processes which are in the ready queue. Then the algorithm will be something like this. Then the quantum time is q. Let us say that there are n processes. Here we have taken an example of 4. P1, P2, P3, P4. So n resembles 4 in the ready queue. And quantum time is q. Let us say that the time is 10 milliseconds. Then each process gets 1 by 10 of the CPU time. This is a calculated formula. There are n processes and Q is a quantum time. Quantum time is how much time it is going to execute in the process. Then every process will get 1 by n of the CPU time and most Q times units at once. And coming to the waiting time, no process waits more than n minus 1 q times. This is also calculated formula. No process waits more than n minus 1 q times. So waiting time has also been calculated in round robin, whereas in other processes we cannot calculate the waiting time. Okay, afterwards only we'll be able to calculate how much the waiting time, what is the minimum waiting. But here before itself, we have a formula to calculate the waiting time. That is what is the importance of round robin scheduling. And most of the processes are going to follow this kind of pattern only. Then coming to the next point, timer interrupts every quantum. That is, after 10 milliseconds or after 20 milliseconds, every process is been interrupted. Every process has been interrupted and it will go back to the ready queue once again. Okay. So as I've said, it is going to follow the order of FIFO. One minute. As I've said, it is going to follow the order of FIFO method. The FIFO method is the one which is okay. Suppose the quantum time is very large. So most of the time, it is going to follow a method called as FIFO method. Suppose the quantum time is small. If the quantum time is small, then Q must be large with respect to quantum switch. Otherwise, overhead will be too high. Make sure the quantum time is not too small or not too high. It has to make sure the quantum time is going to be few, because if the quantum time is very less, suppose if the quantum time is very less than what we expected, then the interrupt, it has to move from the running state to the ready state. That interrupt time is also going to be calculated. So when that interrupt time is calculated, the interrupt time is going to increase. That is, it has to move from running state to the ready state. So at least 1 millisecond will take from move from ready state to the running state to the ready state. So as the interrupts are more, the interrupt time is going to increase. So which will increase the overhead of the system. So make sure whenever we take the things, we are following the proper quantum time. Okay, make sure the quantum time is also not too small. Okay, then only the things are going to be perfect. Otherwise, we cannot make sure that the things are perfect. Clear with this, ma? Everybody? I hope everybody is clear with this.
Yes, sir.
Fine. Okay. We'll see an example for this. We'll take the similar kind of example. But only thing is, well, I'll try to change the values here. We'll take the first time as more. And we don't require the priorities here. Okay. So this is a process. We have taken 5 processes and the press time is so and so. Now we'll take a time quantum. Time quantum for all the processes. Let us say the time quantum is about 10 milliseconds. Okay, let us say the time quantum is 10 milliseconds. Okay, I hope all are clear with this now. Now we'll take the diagram. Excuse. Now, as I've said, the process are going to execute in the same order. So, order of execution, let us take something like this P1 followed by P2 followed by P3 followed by P4 followed by P5. So order of execution is also going to be in the same order as we have taken the processes, first come, first serve method. Okay. So here, what is the quantum time? Every process, remember, every process is going to execute for only 10 milliseconds, as the quantum time is 10. Remember, the quantum time is 10. So every process is going to execute only for 10 milliseconds. It will not be execute more than 10 milliseconds. So the process P1 is going to start the execution at the beginning. At the beginning, the process P1 is going to start its execution. Okay. The beginning P1 is going to start the execution, and it is going to start the execution at 0th. You're going to start the execution at 0th millisecond. Then when it is going to complete the execution at 10th millisecond, complete the execution. Then at 10th millisecond, which process is going to start the execution?
P2.
P2 is going to start the execution. Okay. And at what time it is going to complete the execution? Again at 10th millisecond only. Okay. But here what happens is the time remaining also must be calculated. The time remaining of the process also must be calculated. We'll calculate the remaining time here. Remaining time. Okay. So when P1 has started execution at 0 second, P1 total execution time is 36. Right? So it has executed for how much time? It has executed for 10 milliseconds. So how much is the remaining time of P1?
Milliseconds. 26.
Okay. Then P2 has started execution. And it has executed for 10 milliseconds. So P2 is for 23 milliseconds.
13.
Okay. Minus 10 will be
13.
13.
Right? Then in the same way, P3 is also has to start executing.
P3.
P3 has to start the execution immediately after that. Then how much time P3 will be executed?
30 seconds.
For another 10 milliseconds, P3 is going to be executed. Okay. So it will be executed till 38 milliseconds. to execute the things. Okay. So what is the
remaining 8 milliseconds.
8 milliseconds.
8.
Okay. Then next again, P4 is going to start.
P4 up to 40.
Till what time P4 is going to execute?
P40
40 milliseconds.
second.
Right. So P4
Remaining will be 6.
milliseconds. So remaining is 6.
6.
Then after this, P5 is going to start executing.
P5
P5 is going to execute for 10 milliseconds again.
50th.
To 50th millisecond, P5 is going to execute. So what is the remaining time of P5? Minus 10.
4.
Now after P5, again P1 is going to start executing.
P1
Again P1 is going to start executing the things. Okay. So P1 already it is coming for a second time. So what will be the time now? Up to
60th
millisecond it is going to execute the thing. Okay. So what is the remaining time of P1?
16
minus
16
16. Then again P2 is going to start executing. Okay. So
up to 70 milliseconds.
what? 10 milliseconds.
70th.
Up to 78th millisecond it is going to execute the things. Okay. So minus 10.
3 milliseconds remaining.
Okay. Then P3 is going to execute followed by P3 can execute for 10 milliseconds, but it is having only 8 milliseconds. Remember this.
8.
P3 can execute for 10 milliseconds, but it is having only 8 milliseconds. So it will execute only up to 8 milliseconds. It will execute only up to
8 milliseconds. 78.
78.
It can execute only up to 78 because it is having only 8 milliseconds, right? Minus 8 is equal to 0. Then
Remaining 0.
P4,
P3.
everybody is following this.
Okay.
Everybody is following this, right? Then P4 will be
Yes, sir.
Yes, sir.
6 milliseconds. So from 78 to 84. 78 plus 8?
4.
80.
84, sir.
Okay. So up to 84, P4 is going to execute. So P4 is also 0 now. Okay. Then P5 is going to execute the thing.
88.
In what time? 4 seconds.
88.
88. So P4 is also going to, P5 is also going to finish the execution. Then again P1 will
P1.
start the things. Okay. P1, how much? It will
98.
full range.
98.
It will go for full range of execution. So it will be done till 98.
8. Remaining 6.
So you can go up to 98. So again minus 10 is equal to 0. Then P2, it has something. So it can also start executing.
Sir, 16 minus
Sir,
10
remaining
is
time
6, no, sir.
Yeah, sorry. So P2 again is going to start executing.
101.
How much time will it? What? 3 milliseconds.
101.
101.
I'll extend this. Then after P2 has completed execution.
0.
Then P1 is remaining. So again P1 is going to be going
Up to 107.
up to 107.
107.
107. So these are the execution is going to be done. Clear? Able to follow this, my everybody?
Yes,
Yes,
sir.
sir.
I hope everybody is able to follow those things.
Yes, sir.
Okay. Clear with this? Like this, the things are going to be executed until it has completed the things. The remaining time has to be 0. Until the remaining time is 0, it will continue its execution. It will go on continuing its execution. That is how the round robin scheduling algorithm is going to work. Clear with this, everybody? Follow?
Yes, sir.
All are able to follow this? Is anybody
Yes, sir.
follow this? Everybody is able to follow this, right?
Yes.
Yes?
Yes,
Any
sir.
doubts?
Yes,
Sir.
sir.
So these are the things are going to execute in round robin scheduling algorithm.